Good morning. So, in this lecture, we will deal with this topic, that is total productive maintenance. So, that's what we are going to discuss in this thing. So, basically, we will be seeing about the overall equipment effectiveness. In this slide, I'm showing in as equipment effectiveness.
Science.
Sometimes it is called overall equipment effectiveness, that is OEE. So, how to calculate the OEE and why this TPM is very important. So that's what we are going to discuss in this class. So this TPM,
So,
that is total productive maintenance. So these words, what is a total? The total means all encompassing by maintenance and production individuals working together. So that is what very important. So when you work in an industry, you will understand that the production people and the maintenance people will not work together because their production, the production people, their performance depends upon the maintenance people. And you know very well, any equipment, for example, if you are running for 3 shifts, so for example, mostly industries, most of the machines will run for 3 shifts, that is 24 hours completely they will run. Maybe 1 hour, some gap will be there. So if the machines, if you are running for 23 hours per day, naturally some breakdown will be there. So it is usual. So not like our equipments. For example, if you purchase a refrigerator, and you know very well, refrigerator, one component is very important. There is something called compressor, which is going to be very important. And you know very well now all the latest refrigerators, the compressor will not run for 24 hours. Night time it is not going to run. You know, refrigeration, you know. And if you are buying a refrigerator, for first 5 to 6 years, it will run. Nothing will be there. If you have a voltage stabilizer, refrigerator will run. And even if you take our fan also, even if the fan is running for 24 hours a day also, without maintenance, the fan will run for 3 years. But industrial machinery is not like that. So all the machinery, if you are running for 24 hours a day, there will be breakdown. So they will not run. So naturally, there will be friction between the production people and the maintenance people. And please understand, the maintenance team will be maintenance crew will be very small team. Sometimes, some 10 missions simultaneously, they are not working. Only one mission they can attend. So always there will be, so they have to cooperate together. So then only quality is going to come. So if the mission is idle, if the mission, there is a breakdown and for 6 to 7 hours, if the mission is not being repaired means, so that is, so this total, why this total productive maintenance is, the maintenance people and the production individual should work together. Even for a very small example, and there should be cooperation because small level they should try to rectify the mistakes. Okay. So for example, this is the problem with computer printers. So now the people who are handling them, they may not be experts. So even our secretary also, you take she knows something about the printer. Every day you can, because printer every day you cannot make, because we all VAT printer, computer printers, they are AMC. There is something called AMC, annual maintenance contract. So every day you cannot make a phone call and ask them to come and other things. So small things they should be able to do. The person who is working with the machine should be able to do some maintenance or something, so that the machine is working. Every time you cannot go to the maintenance people. So this maintenance people and the production people should work together. So that's what as far as this total productive. And then productive means production of goods and services that should meet and exceed customer expectation. So that's what in the TQM we are seeing. So whatever customer requirement or customer expectation, we should try to exceed and we should make the customer happy. And then maintenance, keeping all the equipments and plant in good condition or better than the original condition. I don't know, original condition is better than the original, because once first 2 years, all the machines will work nicely. Any machine, if you take new machines will work. So, there will be degradation. That's what we are going to see in reliability, because all materials, they have their own problems. They have their own problems. So after some time, they are going to create problems. So we have to, what is the main job of the maintenance people is to keep all the equipments and machines as well as the plant, in the good condition. So that is the main function of the maintenance. Yeah. And if you see the maintenance, there are some 3 or 4 types of maintenance. The first one is called the breakdown maintenance. So what is a breakdown maintenance? That means you are not doing any preventive maintenance or predictive maintenance. So what is the thing is, the machine fails, machine is not working. For example, the lathe, the motor is not working, it's not rotating. So that is breakdown maintenance. So immediately it has to be attended, and then only, otherwise the production will suffer. That is called breakdown maintenance. And the second category is called preventive maintenance. So what is the preventive maintenance? To keep the machine in good conditions, we have to do some small things. For example, cleaning is very, very important. I don't know whether you will understand that. In any equipment, we have to clean them. Otherwise, even laptop you take now, if there's a dust in it is, so sometimes it may not, the laptop may not work if there are too much dust is there. So that's the problem with electronic components also. So any component, no, we have to do some preventive maintenance, just like cleaning. And you know very well, mechanical components, if there is any sliding component, so we have to provide lubrication. So how do you do that preventive level? We can have some charts, something like that. Daily maintenance, weekly maintenance, monthly maintenance. Even very brief period I was working in a maintenance. For 6 months I was, when I was in Solidar working in, that is way back in 1989, very long back. I was in the maintenance only. So I used to prepare daily. So daily we have to see whether all the oil lubrication, there will be, the oil will be there in the can, whether that oil is available. The next step, filters. We have to clean the filters every 10 days or every 1 week. Cleaning the filters, lubrication, getting lubrication, cleaning them, and occasionally retightening the nuts. Sometimes not due to vibration or something like that. Machines bolts and nuts, all the fasteners will be loosened. So we have to retighten them. So all these things are preventive maintenance. So we have to do that. This may not result in breakdown, but we have to do. So we have to have a maintenance people, they should have a chart daily what they have to do. Visual inspection sometimes we have to. Even laptop also, everything, all electronic components. So visually we have to do inspection, or we have to clean them, we have to lubricate them, clean the filter, or retightening the bolts and nuts, fasteners. So all these things are preventive maintenance. Now there is another thing called predictive maintenance. Now you know very well, there are sensors are available. For example, in the lathe, there is something called tool will wear out. So in case of lathe, I don't know, I think 19 BME students, you are 18 BME students, I think they had some exposure to machining process lab. So you have seen only videos, but of course you might have seen lathe and other things. So whenever there is a lathe, the tool, suddenly sometimes the tool will wear out. If you are not noticing that, the surface finish of the component will be. So the tool is wearing out. Suddenly sometimes the tool will, due to some unknown reasons, tool will wear out. So the finish of the component will be very poor. Finish of the surface finish will be very poor if the tool is wear out, it is worn out. So now we can do predictive maintenance. So condition monitoring, we can have a sensor which can find out whether the tool has wear out. Whenever there is a tool burn, immediately alert message will come. The tool has wear out, or otherwise surface finish is poor, is very poor. So we can surface. So online we can. So we are having some sensors for that. So that is called predictive maintenance. So all these type of maintenance are. So what is the main thing of this TPM is that maintenance people and production people will work together, and then so that we are going to see the machine should be available all the 24 hours. So that should be the main idea. So if all the machines are maintained properly, the machine should be available. The machine is not available, production will be affected. That's what we are going to see. And 3 metrics we are going to see. Not only the availability, we are going to see other one, performance and as well as quality. So at the end of the day, the quality of the product is going to be very good. So what are the overall goals of TPM? That is total productive maintenance. Maintaining and improving the equipment capacity. Capacity means equipment should be available for 24 hours. And you believe me, many times in an industry, it will not be available for 24 hours. Due to, because if you are running, naturally, problems will come, breakdown will come. So that breakdown has to be minimized. That means, in other words, the availability of the machine should be increased. Availability should be. Ideally, 24 hours is not possible. Because we need some breaks. Because even if you take 8-hour shift, the employee, the worker will take coffee break. He will take a lunch break, some rest. So these are all unplanned, what you call unplanned reason due to some. So all exactly 24 hours, the machine cannot run. So maintaining and improving the equipment capacity is very important. The maintaining equipment for the life. As I told you, initial stages the machine will run. After 5 years, there will be trouble. So using support from all areas of operation. Always don't depend on the maintenance because they will be very few in number. So sometimes you try to solve the problem. Encouraging input from all employees. So this is very important. So many times, if the printer is not working, the secretary will be able to give you because we are not using the printer daily. So she is using it daily. So she can tell if the printer is not working. Because based on experience, because all the 8 hours she has been using the printers. So using the teams for continuous improvement. So these are some of the overall goals of total productive maintenance. TPM means total productive maintenance. And there are some 7 steps. So first, the management should learn the new philosophy. Many times, this is not taken seriously. Always, this is any mission, immediately maintenance people. Always, it's very difficult maintenance person because always they will be under pressure because productivity is suffering, productivity is suffering. So many times now they have to diagnose what is happening. It takes some time to solve the problem. So what is that? Preventive maintenance, predict, all these things should be taken care of. So the senior management, the management of the company should learn the new philosophy. And the next thing, they should promote the new philosophy. Here that preventive maintenance is going to be very important. And then breakdown, if at all there is a breakdown, immediately it should be solved. Then only the production should be. And training should be funded and developed for everyone in the organization. So as I told you, small things, always you should not depend on even the operator himself should be able to. So he should be provided some training. So if at all some small problem is there in the machine, he should be. So for example, changing a bearing is very difficult. For example, in case of bearing, there is a nice any rotating component. There will be, for even in case of lathe, there will be a bearing. Sound is coming. Changing a bearing, is not easy. Some trained maintenance person has to come. So some small thing is there. The operator should be trained. So for that, it should be funded. The areas of needed improvement are identified. So here only there are 3 important metrics. So I told you availability. Second one is performance measures, and third one quality. So how to find out the overall equipment effectiveness? That we discuss. And then once you have that overall equipment effectiveness, that number should be 85%. So normally 85 to 90% is a good number. 100% is very ideal. You cannot have 100. That means all the 24 hours the equipment is available. Quality, there is no defective products. All the products are good products. These are all very ideal conditions. Same way, there will be some losses. Performance will not be 100% efficient. So 100% is very ideal. So we have to aim for something 85%. Typically, we have to for 85%. 90% is also fine. So then fifth stage, we should have goals. So once you know the equipment effective numbers, how to, for example, in the example, what I'm going to show, it is coming 74%. So then all the stakeholders should sit together and they should have goals, how to make it 85%. And then an implementation plan is developed, and then work groups we must form. So critical missions, we should have a work group. So they should decide how the equipment effectiveness, that is OEE, overall equipment effectiveness, can be increased to 85%. And there are 6 major losses. So before going into the metrics, we are going to have some. So these are all some downtime losses will be there. So initially starting, first day you starting even laptop, it took 10 minutes today. it took me 5 minutes. Many times it is taking 10 minutes. So initial startup, there will be some losses. Shift changes. So one operator will go, the next operator has to come. So there will be some gap. Automatically, there will be some gap. Coffee and lunch breaks, because human being, you cannot work continuously for 8 hours continuously. We need some breaks. So at least not necessarily for because 8 hours at least we need coffee or we need lunch and other things. Operators, so the planned maintenance shutdowns. So sometimes for some critical machines, they have to be stopped for some time. We have to do some maintenance. Then only the next shift. So these are all planned. It's not breakdown. These are all not breakdown. So startup, there will be some trouble. Shift changes, there will be trouble. Of course, when it comes to laptop, always, even if we go to our CTS, they will say, you restart. That is a thing. Even or sometimes even CTS, because I have some 10 years, I have been using laptop. So one is we have to restart. Still, it is not working. What do you do now? You take out the battery. Once again, you install the battery. So these are all some tricks, but still sometimes they may not work, because fortunately, what I have done is I have purchased one more laptop. So I am using two laptops, because in this COVID period, we are using laptop for so much time. Just like 8 hours, 9 hours, we are working. So these are all planned losses, downtime losses, unplanned down. So breakdown will be there, changeover will be there, lack of material, and then reduced speed losses, idling and the minor stoppages, and then slow down, and then poor quality losses, process non-conformities, that is defective part, defectives. So that is fifth one, sixth loss. And then idling and minor stoppages, slow down. So this you must understand. So for example, if you take a bus, it is not able to run at the speed. So we have to reduce the speed and we have to run the bus. The reason being vibration is there. So the bus can run at maybe 60 kilometers at so much RPM. But the reason is we are trying to reduce the speed. The reason is so much vibration is coming out. So these type of things are called performances. Ideally, the bus can run at high speed, but because of vibration, so that is called performance efficiency. So the bus can run at this RPM, 1000 RPM. But the reason is, since vibration is there, we cannot run at the buses 1000 RPM. We have to run at some 800 RPM, something like that. So these are all called speed losses. So this is performance. And then finally, quality losses. So fifth means defects, and the sixth means scrap. So these are all the six major losses. First two we have some what you call availability losses. First two losses are availability losses. Next two are performance efficiency. That is third and fourth. Third and fourth are performance efficiency, and 5 and 6 are quality losses. So these are 6 types of major losses. Now downtime losses we have to find out by equipment availability using this equation. So availability is nothing but T divided by P. So T is the operating time, P is the planned operating time. So downtime is T. So P minus D is T. So operating time. So availability. So this will be a percentage. This will be a percentage. So planned operating time, denominator is going to be so much time. So we have one example where I will show. So this availability is nothing but whatever available time. So P minus D. So P is the planned time minus downtime. So this downtime we have been discussing, coffee break, all these things. So that we have to subtract from the planned operating time. So that is called T. So that is operating time we are getting. So planned operating time, we are subtracting the downtime. So we are getting available T by P, which is going to be a percentage. And the next one is speed losses. We have something called C into N by T into 100. So these are all second type of cut. So 3 metrics are there. One is availability loss. The second one is speed loss or performance loss. And the third one is quality loss. So in case of speed loss, we have C into N. C is the theoretical cycle time multiplied by N, number of components, process number of components, divided by T. So T is nothing but total thing. So C into N by T will give the performance efficiency E. Because E is nothing but theoretical cycle time into N divided by T. T will solve the problem. There we'll understand. So T denominator, I think they have not given what is T. So T should be the ideal, and that I'll tell you, solve the problem, we'll see. And then third metric is quality loss. So quality loss R is given by N minus Q divided by N, where N is the processed amount, total number of, that is denominator. And then N, you subtract the non-conform. Non-conformity means defects. So total quantity is N minus defects. Q means don't take quality. So it's a non-conform quantity. That is a Q. Why they are given Q is quantity of defects, quantity of defects. So total is N minus defect, that means good ones. Good ones divided by total will give the quality. So these three, that is previously, first one is A, which is availability loss. Second one is E, which is efficiency, performance efficiency. Third one is R, quality loss, rate of quality products, rate of quality. So these three performance metrics are very important. And from this, I am calculating the EE, means equipment effectiveness. You can have OEE also. Many textbooks, they use the word overall equipment effectiveness. So this overall equipment effectiveness is nothing but A, which is availability loss, E, which is performance efficiency loss, R is the rate of quality products. How many quality products are there? So all of them will be in percentage. So availability is so much. That means total, for example, total time. Just for a good example for you to understand, the availability of the machine, total time availability is for 24 hours, means 24 into 60, so many 2,400 minutes availability is there. But so much time it will not be available. So how much time it's available? For example, 90% of the time it's availability. So that is called availability loss. Next one is efficiency. So even though the RPM is 1000 RPM, we will not run the machine for 1000 RPM. The machine is capable, because, for example, in case of the lathe, you will understand. If you run for 1000 RPM, for example, if the lathe motor can run for 1000 RPM, sometimes we cannot run it for 1000 RPM. With the old machine, vibration will be there. If the vibration is more, the surface finish will be very poor. So even though the machine is capable of running at 1000 RPM, we will run only at 800 RPM. That is called performance. 80% only performance, even though it is capable of running it. Because if it is running at 1000 RPM, the productivity will be more. So that is called performance efficiency. And the rate of quality. For example, 100 products are produced, 3 products are defective. That means 97% is the rate of quality. 97% is the rate of quality. So if you multiply all the three, that is availability, E, ideally all of them should be 100, and you know very well it cannot be 100. But even if this is 95, this is 95, this is 95, the overall equipment will not 95. You know very well 0.95 into 0.95 into 0.95, it should be much less than 95. So this is called overall equipment effectiveness. So here we have an example. Just I'll show the example and then we will stop. So this example, the operation is for 10 hours a day, 5 days a week. So this is the data given. The downtime due to meetings, material outage, sometimes material will not be available, training, breaks, and everything. It's 400 minutes per week. The downtime scheduled and equipment downtime. So this is manufacturing downtime. So due to manufacturing, we know coffee break is there, meeting is there, material is not available. It's just downtime due to manufacturing is 410 minutes. And the due to maintenance, 227 minutes per week. The cycle time is 0.5 minutes per unit. Production for the work is production for the week is 4,450 units, and the defective parts is 15 units. So first one calculation we will do, and then we will stop. Wednesday we will see the remaining thing. So we have to find out what is the planned time. So which is nothing but 10 hours a day, 5 days a week, 60 minutes per hour. So totally how many? Because other units it's 227 minutes per week. So we want to make it into minutes per week. So what I'm doing, it is given in the problem, 10 hours per day, 5 days per week. So into 5. So we want the days, already hours we have 10 into 5. That means 50 days a week, into 60 minutes each. So per hour we are getting 60 minutes we are multiplying, and then we are getting 3,000 minutes per week. That is the total shed time, total time is going to be 10 hours into 5 days, 10 into 5 days a week we are working, and 60 minutes. So per week, the machine is being operated for, the equipment is being operated for 3000 minutes per, just simply multiplying, we are multiplying. And the D, that is downtime. There are two types of downtime. One is due to manufacturing and the second one is due to maintenance. So 410 plus 227, it is coming to 610. That means the equipment is not available. Straight away, what you understand? The equipment is not working or is not available. So basically, it is an availability loss. So 410 minutes due to some meeting, material outage, training, and other things, it's not available. And due to maintenance, it's not available for 227 minutes per week. So totally it comes to 637. So T, the availability is nothing but 3000 minus 637, which is 2263. That is, availability is only 2263, sorry, 2363 out of 3000, So next slide I'll show you. So the availability is nothing but T is nothing but its available time, 2363 minutes. The total time is 3000 minutes. So into 100 we are, so we are getting 78.8%. So out of the total 100% time, only 78.87% of the time only the machine is available. So the remaining 21.2, it is going in the form of meeting, maintenance, breaks, and other things. So it's available only for Sunday. With this, I will stop for this class. We will continue on Wednesday. Only another 10 minutes I can complete, but the only thing is very important. That's why we will see it on Wednesday. It is about productive maintenance. So the only thing is I have not given the assignment till now. So today, 100% I will give the maintenance. I will give the assignment, digital assignment 1. I will give 15 days time. So today is 21st. So you can submit up to March 5th. So I'll use some FMEA. I'm planning to give one FMEA and one Kano model. So two things I will give. So you try to complete 15 days time I will give. So by March 5th, you must submit the first assignment. Still, I have not given because I was busy Saturday, Sunday I was busy. So that is about digital assignment 1. I'm correcting the papers. So still it will take some time. Though our events class. So, yes, tell me.
So once you had given some fish diagram on online classes or something, was that evaluated or not?
No. That I have not evaluated. Because we are having so much thing, I have not evaluated. So that is not that is for one day. I have not come. No, that during the class I will evaluate some other time. That online classes I have given. No, okay, that I will evaluate. But this officially one digital assignment, one thing should be given. One day on the class I have given that. I have not evaluated that. I will evaluate because these days, no, we are very busy. So much, even Saturday, Sunday also we are having some other work. I will evaluate. Sometime I will evaluate and give my comments. But I'm going to give one more assignment, which will take maybe maximum 1 hour. So that was during class hours. This I will give. FMEA I want to give, and one more Kano model I will give.
So please show the last slide once.
Pardon?
So would you please show the last slide?
Slide, okay, one second. Okay, one second.
No, sir, the next one. I wanted to confirm the answer.
What is the doubt?
No, sir, I wanted to confirm the answer. Yes, sir.
Pardon?
Got it, sir.
Got it, sir. Okay, fine. This is available. This example I have taken from Westerfield. You can look at. But anyway, it's simple. C is the cycle time, and the N is total number. I think 4,004 total number. So we are getting the time. So this is T is also time. So performance. So this already we have seen this 2363. 2363. And this 0.5 is cycle time. We are multiplying by. Then we are getting 94%. And their defects, 15 defects are given. So this Wednesday. Okay. So 1 minute, I'll take attendance.